Okay, Assalamualaikum warahmatullahi wabarakatuh. Basically, this is the last topic regarding our subject, direct digital control. Basically, this is slide that come from others third party lah. That I use some of it just to show and to teach and example that come from them. So let's have a look what DDC, digital direct control, and how that it can reduce energy or energy conservation by using it. Basically, this is a part of HVAC control principle. So what it intend to control, and then what is control loops, open and closed loops, and how to control cycles, and it's all involved in programming. If you involving control, because you use some sort of microcontroller to control whatever sensor that being attached and whatever loads that being attached to the controller. So let's have a look on the first example. The purpose of temperature control. Basically, this is to control the temperature. If you look here, they have valve over there, the control panel, and you have some sort of this is state status or sense signal directly to control panel. The control panel send the valve, control the valve by control the valve by open or close the valve. So this actually to control the temperatures. So there are key component in control system. Basically, they are sensor, controller, and control device. So these are the three items that we need to understand in the digital control. The first one is controller, control device, and sensors. So what are sensors? Modern HVAC sensors includes, for example, we have here humidity sensor, temperature transmitter or temperature sensor, CO2 sensor for indoor air quality, and we have a power meter also, and we have a branch circuit monitor, and we have an energy monitor. Type of sensor. There are different type of sensor. For example, we have an electric sensor, we have pneumatic sensor, we have an electronic sensor. Example shown here, there appear to be a thermostat. It is remote sensor which remotely set point down and control to another location. So this is a pneumatic sensor being used air actually. And what is it for? Here actually the control sensor means it monitor the pressure and send signal to the controller. Electronic sensor includes resistance sensor, temperature, RTD, and are used in measuring temperature. Example, barcode element, copper, platinum, and 10K transmitter and 30K transmitter. This is type of sensor. Okay, voltage sensor could be used for temperature, humidity, voltage. Typically from 0 to 5 VDC, voltage direct current, or 1 to 11 VDC, or 0 to 10 VDC. Current sensor could be used for temperature, humidity, and pressure. Typically current in 4 to 20 amp. Okay. Basically, when we say to electronic, there are three types in electronic. So that we already know. The first one, we have a V equal to IR. So basically, when you have a controller, and you have a microprocessor over there, and you have an input and output. So all the input and output could be voltage, could be current, or could be resistance. Could be resistance. So either these three types. So by having this three type of input, so we have here, for example, we have here resistance, and voltage, and also we have a current sensor. So either or depends on the design actually, what type they want to use, either resistance, voltage, or current sensor. Here, for example, we have an electronic temperature sensor. Basically, this one, when it measure 1000 ohms, which is equal to approximately 21 degrees Celsius. And as the temperature increase, the resistance increase to changes 2.2 ohms per nearly 4 or 4 ohm per 1 degree Celsius. So if this is 1004, means this is equally 22 degrees Celsius. It's 1002, which is equal to 22 degree. 1008 is equal to 22 degrees Celsius. Okay. Although we have a lot of type of sensor. For example, here we have thermocouple, RTD, thermistor, IC sensor. There are advantage and disadvantage of this sensor. For example, here we have a self-powered, simple, inexpensive. So it depends to what purpose the sensor are. If you want to use, for example, to measure, this is for example IC sensor. It's only going to measure up to less than 200 degrees Celsius. So if you want to measure an engine, so you need to know what is the maximum temperature of the engine. So you could use which temperature that are better for it. Basically, when we have a sensor, a sensor will go to the controller. We have a sensor. This sensor will supply whatever signal to the controller, and the controller send back to the actuator. To whatever. So we need to turn off or turn on the valve, for example. So here type of control that we have electric control, we have pneumatic control, use air, we have also electronic control, and also DDC, direct digital control. For example, here we have this is controller, we have a sensor over here, we have control device. So among the sensor are it could be analog or digital. Analog means if you have it could be very if you have a wave that it could be very like this analog. You could either in the middle, right? Analog signal. If you have a digital signal, means it's either on or off. 1 0 1 0 1 0 1 0 1 0 1 0. This is digital signals, either on or off. So here we have a water flow, we have temperature, we have air flow, static pressure, we have low limit, freeze sensor, we have smoke sensor, we have humidity sensor. This everything will be sent to the controller, and what the controller do? Controller will adjust accordingly, according to your program. If your program here using a C++, perhaps, or Java, or whatever language programming that you know, here just program it, or depends on the controller itself to use which kind of programming. So you program here, and then the control device will do whatever need to be done according to your program. According to your programming. And then, for example, here the valve, you need to cut off the valve. Perhaps the water is already full, and fans, you need to slow down the fans because the temperature is already achieved. Outside air damper, you need to close the dams if there are no humans being on the level 2, perhaps. And then control water supply, chiller. If it's too cold, perhaps open it. And you have a humidifier to increase to humidifier to remove waters. And then we have electric heat if it's too cold. Here is electronic control system in buildings. For example, here is program whatever you need to program. Then it looks like that the temperature is not achieved. So what it needs to do, perhaps it will not using an outside air. You still use the inside air. So everything will be air circulating inside the building. This is example. Jump to control device. Basically, control device is we have here control two-way control device, three-way, and pressure independent control device. So this is a picture of control device. We have also automatic damper operators. what this control device do? Control device do is actually when we have a valve over here is big, so whatever we need to be mix, either open or shut off the valve. Okay. For example, we have to economize the place. Here is the damper that you have looked at. This is parallel blades. This is opposed blades. So basically, when we have a damper inside level, perhaps, or room by room, you have a damper. So when you could control it automatically, so you can close which room that doesn't need or doesn't have human inside it. So you can close it automatically by having a sense that perhaps there's a light sensor, or there is a heat sensor, or their control thermostat that be adjusted is not switched on. So no need to supply air towards that room. So you could control and minimize the cost of your cooling system. This is example of pneumatic, electronic, and electronic control actuator types. This is being connected to the dampers. Okay. Basically, when you have a DDC, the control, you could control either want to pump more, to increase the pump level, to increase the chill, water chill, to open the pump, then the chill water will go and produce more chill water, or you could increase the speed of the compressors, perhaps by having this frequency drive. This is purpose of the DC, digital direct control. Okay, basic control loop. Basic control loop is could be open or close. Close means one close, one round. Close feedback, or it doesn't have any close feedback. Just send whatever you need to be sent. For example, here it sends temperatures is cold or chief, and then you send not to run the compressor. This is close feedback. If open means it's, for example, you already send that is temperature is already achieved, but fan is still moving. Perhaps fan is still moving, so no need, doesn't control at all. Just this is open feedback. Okay. Basic closed loop sensor. For example, here you have a sensor here to measure the airflow. Then you measure this perhaps the flow of the air is already achieved 74 degree. So already achieved 24 degrees Celsius. This is heating coil. Maybe this is cold seasons. Then you can close this water supply. Water supply, normally open water supply. You can close it a bit. Close it a bit. So you will maintain at 24 degree. If you continue supply heating water inside this heating coil, what happen? The heating this airflow will become more heat than before. So maybe this one should be increased up to 25 or above. This is closed loop. This closed loop, then this maintain 24 degrees. Basically, this is example. They going to determine which one is AI, DI, AON, DO. What is AI, DI, AON? DO. AI means analog input. DI means digital input. This is analog output. This is digital output. What do I mean by that? Basically, when we have a controller, perhaps a microcontroller, macam Arduino. So you could have analog input or digital input. You could have DI or you could have AI. You could have AI. Okay, or you could have AO, and you could have DO. Okay, how to distinguish which one to use? So basically, it depends on the sensor itself. If we need to just stop and start and stop means it need either on and off. It means either on and off. It means either on and off. So the graph will be either like this, on off. So maybe this is digital output. digital output, DO. So for example, here you have a valve. Valve means it could not. It depends on if the valve is only on and off. Mean it could also digital. If this is an output, so it can have digital output. But if the valve is to rotate and do a certain leave a certain flow of waters, so it doesn't close and open, so mean this one is digital, analog output. Okay, you need analog output to maintain on certain position. Mean it could open, not only switch on and switch off, but it could have some sort of water level flow. And also this is flow switch. Flow switch, if it's only want to measure either there is air or not, there is air flow or not, mean it could have a digital input. But in the air, there's certain frequency, certain level of velocity of air, you need analog input. This is depend. Okay, so I think that's all for this for these slides. You could read others by yourself. Just jump from slide to slides. Which one is more important for you to know. So that's all for this slide. Thank you.